Hey everyone, welcome to my channel. In this video, we are going to create this amazing parking space finder, and you can say it is kind of a counter as well. So it is telling you how many free spaces do we have and how many spaces overall do we have. So here you can see we have 69 spaces for parking, and out of which 14 are available. And now you can see this car is leaving, this one is leaving as well, so now it becomes 15. So all of the green spots are available to park and the red ones are not available. Now the best thing about this approach is that it is based on completely image processing techniques. So we are not using any deep learning methods or machine learning. It is a very simple method and it is quite robust, as you can see. So here, for example, you can see that there is a person moving, and even when the person is moving, the parking space is still showing that it is available. So it is not affected by a person moving through the space. So it has to be a big object like a car. So if there is something that is as big as a car, then it will detect it as occupied. Otherwise, it is detecting as available space. And you can also see we have also neglected a few of the spaces, and you can see this region. Actually, let me show it you over here. So this region is not the same as this region, and the reason is because it has this line in between. So it's not like you wrote a for loop and then you shifted it over here with another what do you call for loop. So it's basically we have accounted for all these different changes, and here you can see we have an extra space as well, and here you can see we are neglecting the space as well. So all of these varieties and all of these different approaches we have added in our code, and believe it or not, it is very simple and it is a very good project if you are starting your image processing and computer vision journey. So without further ado, let's go ahead and start creating this project because it is quite a lot of fun and it is quite useful as well. As long as the camera is not moving, this technique should work very well. So let's go ahead and start working. So here we are in our PyCharm project, and you can see that we have named it parking spaces. And we also have carpark.mp4 and carpark.img. So these are the two files that we will be needing throughout this project. So the first thing we will do, we will go to File, Settings, and then we will look for the project interpreter. And over here, we are going to add our interpreter. And this will be from the existing environment that we already have. And we will click OK. And that will add our packages here. So here we will install CVZone and we will click on install package. Do remember that this is version 1.5.3. So if there's a later version, you can try that. If it doesn't work out well, you can always go back to this version and try the exact same code and it should work fine. So we will hit OK, and it seems that the OpenCV, NumPy, and the CVZone packages are already installed. So what we can do is we can start off with our file. Now we are going to create two files. One of them will be for the space or the parking space picker. So we will call it parking space picker. And the other one is going to be our main code, which we will run and locate all the parking spaces and see if they are vacant or not. So these two files, by the way, you can download from our website. They will be available for free to download. All you have to do is sign in to your account and then you can download these files. So here in the parking space picker, what we are going to do, we are going to first of all open up our image. And here in the image, you can see that we have a lot of parking spaces. And what we need to do is we need to mark each one of these as our region of interest. Now, one way to do this is using a for loop. So what I can do is I can start from this point and I can say that, okay, for X in range, for example, 15, keep going down and creating these boxes. But the issue is that with that is that these boxes are not exactly of the same size because the image is not perfectly bird eye view. So it's not taken from the exact top, it is taken from a little bit of an angle. So it's not very clear to see. So therefore, we cannot use the for loop because while it starts at the correct position, when it starts to accumulate, the error becomes quite big and we will not be able to get our correct values. So what we can do is we can manually put these region of interest. And another reason why we want to do it manually is because some of the spaces, they are not for parking. For example, this place is for the trolleys, so we don't want to check that. And another thing to note here, that this parking space is similar to this parking space, but it is not similar to the third one. The third one has a solid, what do you call, pavement in between. So you can see here, this is not present in these two. So if we wanted to replicate it 3 times, we cannot. We can replicate this and this, but even then we will have to neglect these two. And then we cannot replicate it here. Plus you can see this is a space which is not available, but over here this space is available. So there's a lot of irregularities within our regions of interest. So it will be easier to do it manually. Plus, we don't expect the camera to move at all. So it will be fixed. So you only have to do this manual process 1 time, and then it will stay like that as long as you do not move the camera. So this is totally worth going through the manual process rather than automating it every single time, or trying to find these lines by default. So if you use a contours method to find these lines, that's just too much overhead that is not required in this project. We can do it simply by some basic image processing. And that is why this is a good project, because we are not using any complicated methods. We are not using YOLO version 4 or 5 or a MobileNet SSD to actually detect the cars. We are simply going to use basic image processing techniques to find the correct car, not to find the correct car, to find whether the car is present or not. So this is a very good way to understand that you don't always need a very complicated method to solve such problems. So we have this image, and then we have this video that will, by the way, the video, the camera actually moves a little bit. I think the video is shot on a drone, so it is moving a little bit, but it should still work fine as long as it's not a very big change. So in reality, if you are doing it on a CCTV camera, then you don't expect it to move. You should have a fixed camera in a fixed position. So in that case, it should be fine. So what exactly are we going to start off with? We are going to start off by creating a file, creating a program that will allow us to select and deselect these parking spaces. We will put them all in a list, and then we will take it to our main code. So one file is for selecting and the other one is for running. So once we select, we are going to save it in a file as well. So the first thing we will do, we will import CV2, and then we will import pickle. Pickle is the package that we will be using to save all the places or the positions of the parking spaces, and then bring it to our main code. So that is what we have the pickle for. And then we are simply going to import our image. So here we are going to write cv2.imread, and then we are going to read our image, which is parking space picker. No, it's not that. It's car park image.png, and we are going to save it in image. So that's simple as that. And then we are going to create a while loop. We will say while true, and then we are going to say cv2.imshow, and we will show our image, and we will call it img, and then we will write cv2.waitKey, and then we will give a 1 millisecond delay. So if we run this, this should open up our image. There you go. This is our image. It is called image at the top here with the title. And yeah, so now what we need to do is we need to create a rectangle around it. So we need to create a rectangle at that exact position. So just for testing, not for actual values. So what we can do is we can write cv2 dot rectangle, and then we will put it on our image. Let's say we put it on 100, and let's say 100. And then the second point is, let's say 150, and the height, or maybe the width will be more. What is the width? It's about 100. So it should be, let's say 200. And then this should be around 50. So let's say 150. Then I believe we have the color. Yeah. So the color, let's put it at 255, 0255. That will give us purple color. And the thickness, let's put it as 2. So let's run that. There you go. So what we are trying to do basically is to try to see what exactly is the size of our rectangle. So once we have that size, then we can fix the width and the height. Then all we need is the initial position. So the x and x1 and y1. This is what we need. And then we will automatically generate x2 and y2. So this is the basic idea. So let's try to find this. I believe we can do it maybe here. So this is 100. So maybe 200 something. So let's say this is 230. And this is a little bit less. So let's say 80. Okay, so this is 230. It should be around here. So this should be around here. So it's much less than that. Let's do one of them at the time, one time. So let's go back 50. I think 50 is good. So the width is good. Now we need to push down the height. So the height right now is 230. Let's make it 270. Oh, sorry. This is the one that is being, okay. Okay, we need to add something here. So let's say this is 500 for now. Let's just put it a big value so that it doesn't interfere. There you go. So yeah, we have already crossed that point. So we were trying to get this one, I believe. So let's say 200. So maybe 20 less, 180. No, 195. Yeah, so a little bit less than that, 192. Yeah, so let's say it is 192, and now we need to know the width. The width, let's say right now is 50 and 200, so it's 150. So let's say we put it at 120, 125. That's less. So we will put it at 140, 170. Little bit less, 160. Yeah, so maybe a little bit less, 157, let's say. Yeah, I think that's good enough. And then we have this, the heights. The height, let's say, is around, this is 192. So let's say 230. A little bit more, 240. Yeah, so I think this is a perfect rectangle that represents one parking space. So 157 minus 50 is our width. So we have width and we have height equals to, so 157 minus 50 is 107. And then our height is 192 and 40 is 48. So let's see if that is fine. So this is the width and the height that we have. And then later on, we can now just put one single place, one single circle or dot, and that will create this width and height rectangle based on the values that we have put here. Okay, so let's keep this. Let's not remove it. Now what we will do is we will put a position list. We will call it position list is empty, and whatever positions we have, we are going to put here. So every position will have an X and a Y. So just the starting point. And then later on, we will add this width and height to it. So for displaying purpose, and we will do it in our original code as well, the main code. So what do we do next? The first thing we will do is we need to detect the mouse click. So to detect the mouse click, what we have to do is we have to write cv2 dot mouse callback, set mouse callback, and then we have to give in the exact same name of the image that we are using. So let's say this is called image. So we will copy that here, image, and then we have to give in a function which we will call if we click on something. So this time we will call it mouse, let's say click. So this is the function that we are going to call. So when mouse click happens, we will write it here. Let's call it mouse click. There you go. So, or let's keep it small, because in Python they want you to have what do you call, they want you to have small names, nothing capital, but I like to add capital because I'm not using underscores. That's why they give this error. Anyway, so we can write mouse click here, and inside the mouse click, what we have to do is we have to call in, we have to add in some parameters. The first one will be events, so it will automatically give us all these events. Then we will have X and Y, and then some flags and some other parameters. So we don't care about these other parameters, but we care about the events X and Y. So what will happen is that we will check if the event is equal to cv2 dot event underscore left button down. So if we are pressing the left button, it's called events. Okay, so left button, if we are pressing that, then we want to append to our list. So what do we want to append? We want to append, so we will write position list dot append. What exactly do we want to append? We want to append the X and Y position. So this is the basic idea of what we will do. And what we can do next is we can display what we have created. So what rectangles we have created. So we can say for position in position list, we are going to draw them, and we can just copy this part because we are lazy. So we will write that down, and then here we will change the value. So the initial value will be position, and the later value will be position at 0 plus width, and position at height plus height, position at 1 plus height. So that's the basic idea. And if we run this, and if we click on something, there you go. So now the rectangle is been created, but it's not been saved per se, but it is been created and you can see it fits perfectly. So this is our first step that we wanted to do. Now, sometimes we press on the wrong place. So we want to delete as well. We should be able to delete because we don't want to reset every time we make a mistake. That will not be a very good idea. So what we can do is we can say that if our event is basically right click button, so we will right click to delete. Then we are going to check if our position point, if our click point is in between one of these positions that we already have, then we will delete it. So we will check that for position in position list, we are going to check what happened there. For position is position list, we are going to get the, let's say, x1 and y1 is equals to position. We are going to check if our current x is in between x1 and x1 plus width. If it's in between that box, and our y is in between y1 and y1 plus our height. So if it's in between that, then it means we need to delete this. So how can we delete? We need to know the iteration number. So we can enumerate. What is happening? Enumerate. Yeah, I don't know what happened before. Enumerate, and that will give us the iteration number I. So here we will say that we want to delete, so we will say position list dot pop, and we want to pop at I. Simple as that. So we will delete the I value, whatever is in the I value. So if I press in the left mouse button, it will create, and if I right click, oops, it did not delete. So it should delete. But it's not deleting. Why is that? The concept is fine. cv2.waitkey. Okay, that's fine. If events is cv2 right button down for I and position and enumerate lists. Oh, okay, I know why it's not deleting. Because our image is imported once. And whatever is drawn on it, it will remain the same. But webcams, they don't work like this. Webcam will generate a new image every time, or a video will generate a new frame every single time. So this is a static image. We need to import it again and again within the loop, then it will get deleted. So in the video, we will not face this issue because it is automatically generating new frames. So here, if I click, oops, I made a mistake. Boom, gone. Boom. All of them empty. So this is the basic idea of how we can create these rectangles and how we can delete them. But right now we are not actually saving them. We are just creating them. So to save them, what we need to do is we need to store it in Pickle. Not store it in Pickle, but store it using a Pickle object. So how can we do that? Now, the first thing we want to do is to see if there is a Pickle object or not. or let's do it later. Let's do it later because that might confuse you a little bit. So let's do that later on. And what we will do is every time we append and every time we delete, after that, we are going to um, add to our pickle object. So what we will do is we are going to write here with open, and then we are going to write the file name. Here we are going to call it, let's say, car park positions, let's say. And then we are going to give in the read and write permission. So we will write WB and we are going to write as F. And then within that, we are going to write pickle dot dump. And what exactly do we want to dump? We want to dump the position list in the F, in the file. So this is the basic idea. So what we can do is we can run this. And if I click here, now you will see there will be a new object that is created here, a new file. If we stop, you will see there is a car park position. So this is our pickle object. Now, if I run it again, what it will do is it will overwrite the previous one. But we don't want that. What we want is that it keeps the old one. And then if we want to add or edit or delete, whatever, we can do it from there. So to do that, we will copy this part. We will copy this part, and in the beginning of the code, we are going to check if there is a position, if there is an object or not. So we are going to write with open all of that, but with RB as F, and then we are going to check if we have that, then we are going to put our file in position list. Rather than creating a new list, we will say position list is equals to pickle.load the file F. So whatever is in file F, put it in position list. So we are going to try to do this. We will try to find it. If we don't find it, then we will write except we are going to create a new, empty list. So that's the basic idea. So now if I run this, you will see the previous drawings are already there. The previous markings are there. So we can delete, and only one is remaining now. And I can put another one here. So now we have two. Remember that. So if I stop this and I run it again, now I will have only two. So that's perfect. So if I wanted to keep adding more, I can add here. And then if I made a mistake, if I went to my code and tried it out, it's not working well, I need to change a little bit, then I can run this again and I can see, okay, this one is not good. I will delete it and I will click on it again wherever I want. So this way it is much easier and it is more efficient than actually doing it again and again from the beginning. So for example, here you can see I added a gap here. So I can delete it and then I can start again. So now there's no gap. So this is the way we can sort out all our boxes. And once we have these boxes, we can go to our main code. And this main code is going to use this car position park. So now that we have our parking space picker, what we can do is we can create a new file here and we will call it, let's call it main.py. So here we are going to import CV2. We are going to import pickle and we are going to import CV zone. And we will also import numpy as np. Numpy as np. So these are some of the libraries that we will be needing later on. And I will explain why do we need each one of these. So the first thing we have to do is to open up our video. So here we are going to write that this is our video feed. So the video feed is over here. So we can, not here, this is carpark.mp4. So we can write cap is equals to cv2 dot video capture, and then we can simply write carpark.mp4 dot mp4. So this will add our video, and then we can write here while true, then we will get the frame from our video. So we will write here that the success and the image is equal to cap.read, and then we are going to write cv2.imshow, and we will write image and image, and then we are going to write cv2 dot wait key is 1 millisecond delay. So this should be enough to run our main code, and there you go. Now you can see the video is running, the cars are moving, they are moving quite fast because the computer is able to process it with more than 30 frames per second. The video is 30 frames per second, but it can process it faster, so it finishes faster. This whole video is about 29 seconds, but you can see it took about 3-4 seconds to do the whole thing. So that is quite a lot. Yeah, maybe 5 seconds. Anyways, so the first thing we need to do, we can slow down the video. We can simply write here, for example, 10, and that will slow down the video. But what we need to do really is to loop this video, because we don't want to keep testing by pressing the run button again and again. So we want to loop it. So to loop it, what we can do is we can check its frame. So we will write here if cap.set, not set, cap.get, and we will write cv2.frame cap prop frame count. I think that is the cap prop position frame. Yeah, this is the one. So this will give us the total frames that we have in the video, and then we are going to check the current frame. To check the current frame, we are going to check cv2. No, actually this one, this is the current frame, and now we are going to check the total frames. So it will be the same cap dot gets, and then cv2 dot prop underscore frame count. Is it frame count? Prop frame count. Yeah, it's the same. So this here is giving us the current position, and this here is giving us the total number of frames that are present in the video. If that is the case, then we are going to write cap.set, and we will write cv2.cap underscore prop underscore position frames as 0. So we are resetting the frames if they reach the total amount of frames that the video has. So if we run that, actually let's put it at 1 again so it's faster, so we can tell if it's going to shut down or not. So it is running, and there you go, it started again. So you can see here when the person actually throws the trolley here, there you go, then the video ends. So you can see that happens quite a few times, so it is repeating. So we can put 10 here back, so it will slow it down a little bit. So that is what we need, and now we are good to go and ready to run our code. So the first thing we can do is we can import all the positions that we have. So in the parking space picker, so what we can do is we can use the same method of loading. So this time around, we do not need to try, because we know there is a file that has all this information. So we can write here with open car position this, and this position list is equals to this. So now within our position list, we can display all the, what do you call, positions by copying this part here. using our rectangle method. And there you go. And the width and the height we need to declare again. So the width and the height we can copy and we can paste here. So if we run this now, actually let's put it on one side here. No, put it back there. Okay. So now if we run that, we should get it with our image. Where is the problem? Image is not defined, really? Main. Oh, okay. So we need to put this over here. My bad. So let's run that. There you go. So these are all the position points that we are getting from our position list from our picker. And now they are over here. So this is what we can easily do. So this is all well and good. Now what we need to do is we need to crop all of these regions. So actually what we can do is we can put it in a function. Let's just call it check parking space. And we'll put the checking of the parking space in this code, in this function. So here we can remove this part and we can put it here. And we can just call this function over here. And that should be good to go. Yeah, same effect. Okay, so here what we are going to do, we are going to, first of all, we are loading all these rectangles. Now what we need to do is we need to crop our images one by one, and then we need to check how many, we need to find a way to find if there is a car inside that or not. So first of all, let's just crop. So here we are going to write, so let's call this X and Y is equals to position. And then to crop it, we can simply say that our image crop is equals to image. And then we are going to give in the initial position. So the initial Y, it starts from Y. So it will be Y and then Y plus height. So height. Come on. Something is wrong. So this is the height. So this is the one we are talking about. Then we will say that our X and then X plus width. So this will crop it and we can write cv2 dot im show, and then we can show the image cropped, and we can write here image crop. But because it will do it for like a lot of them, so we can do it after the for loop. So it will just show us one of them at the very end. Or if you want to see all of them, we can do that too. We can write here, string and then X. So X will be a different value each time. So, or no, it will not be. So X, let's say X multiplied by Y. Let's say this is the name of the image. So we need to have a unique name of the image so that it doesn't overwrite. So it will show us all the different images that we have. So there you go. So these are the cars that we are getting. So each car is a separate image. And it's a good point that we have seen here. Each of these should be drawn later on. So not before you crop. This drawing should be done after the crop so that it doesn't have that purple region around it. So if we run that, wait, it still has it. Why does it still have it? Oh, it's not having it. Maybe of the, it's of the one above it. So maybe we should draw it at the very end, like in a different loop. So we can write here after doing that for position in position list, and then we draw. Wait, what happened? Oh, I pasted the wrong thing. Let me go back. Cancel, paste. For position in position list, we write it like that. So if we run this now, yeah, now you will see there is nothing, no lines on the sides. So now what we need to do is we need to find for each one of these, we need to tell whether this region has a car present in it or not. So how can we do that? We can do that by looking at its pixel count. So we need to convert this image into a binary image based on its edges and corners. And then from there, we can say that if it doesn't have a lot of edges or corners, then if it's a plain image, then it means there is no car. But if it has, then it means there is a car. So how can we do that? First of all, we have to do some thresholding. So to do some thresholding, what we will do is after we get our image, we are going to convert it into grayscale. So we will write here image gray is equals to cv2.cbt color, and then we will write that we want to convert our image and we want to convert it into color underscore bgr to gray. So we want it to convert it into gray. And after the gray, we can also add some blur. So we will write here image blur is equals to cv2 dot Gaussian blur. And here we are going to add the value of our image gray. And then you have to give in the dimension of the kernel. So the one that I found is useful is 3 by 3. And here we give the sigma x as 1. So these are the values that I played around with, and I found that this is a good value. Feel free to play around with these values and you can find your own, and hopefully it will be better. So we can check the result of it. We can copy this and paste it here. We will write here image blur and we will write here image blur. So if we run that, there you go. This is our image. Now, where is it? There you go. This is our image. It is gray and now it is a little bit blur. So it's a little bit hard to see, but definitely there is a little bit of blur. So that's good. After the blur, we are going to convert it into what you call a binary image. And we are going to use threshold. We are going to use adaptive thresholding. So we will write cv2 dot adaptive threshold, and we are going to give in our image blur, and we will give in the maximum value as 255, the method as adaptive cv2 dot adaptive threshold Gaussian c, and then we are going to add a binary inverse. So cv2 dot threshold binary inverse, and then we have to give in the block size. Again, these are the values that I found to be useful, but again, you can have different values. The ones I found were 25 and 16. So these are the values. Again, you can play around with these values. You can even add track bars. I will add the code for track bars later on, and it will be on the website. You can download it from there. You can also add track bars and you can move these track bars to check which value is the best. So if you want to play around with that. So let's check out the image threshold. How does it look like? So image thresh. Let's run that. And there you go. So this is what we are getting. Okay, so if we have a closer look here, you can see wherever there is a car, for example, let me write it here. So for example, here, you can see there's a lot of white pixels. There are some pixels there. You can see here, there are some pixels. But when there is no car, you can see there's very few pixels. Here you can see the car is leaving and the pixels are almost negligible. So the number of white pixels. The same thing over here. You can see the number of pixels are reducing. Here you can see there is no car. This whole region we are neglecting, so there is nothing there. So that's a different story. But other than that, you can see here as well, here as well. So this is a good indication of whether there is a car present or not. Again, how did I find this? By changing the values, by changing the Gaussian value, by changing the what do you call, the adaptive threshold. So you have only two values here, and you have one more value you can add, which is basically the median blur. So there is a little bit of, you call, what do you call, salt and pepper noise, you can say, little bits of dots here and there. So to remove these, you can use median blur. So we can write here image threshold, or let's say image median, is equals to CV2 dot median blur, and then we have to give in our image threshold, and we have to give in the value for it. So the kernel size, the bigger it is, the more it will affect. So the kernel size that I found it useful was 5. So let's run that. Actually, we need to display the median now. There we go. So now you can see a lot of the dots, they are removed. They are, well, they are less than before. Now, sometimes these pixels, these values, they might be a little bit thin. So what we can do is we can make it a little bit thicker so that it's easier to differentiate between empty spaces and when there is a car. So to do that, we can use dilation. So we will use the morphology function, and we will write here image dilate is equals to CV2 dot dilate. So it's not dilate, it's dilate. So image dilate, and I didn't put the G, image dilate. And then we are going to give in our image. So it will be image median. And then we have to give in the, I believe, the kernel. So the kernel, you can't just give in the size, you have to give in a kernel. That's why we had to import NumPy. So we will use that to write it down here. So here we will write kernel is equals to numpy dot ones, and the ones will be, let's say, 3 by 3. So this is the value that I found was good, and we will write numpy dot integer of 8 bits. So this is the idea. Actually, you have to write unsigned integers of 8 bits. And here you have to give in the kernel, and then you have to give in the iteration number. So iterations is equals to 1. You can give more iterations, but it might get a little bit too thick. So you have to be careful. So there you go. So all these have a little bit of effect, but together they really make up the whole algorithm, and it makes it work quite nicely. So now is the moment of truth. We need to take this image and we will crop this image one by one. So instead of cropping, what do you call, actually we should have an image here. Let's say img image, let's say processed, let's say PRO, image processed. So we will send in our image dilation as our image processed. And then the image processed is what we are going to crop. So if we run that now, you will see all these are the ones. So now we need to count the pixels, how many pixels each of these car spaces has. If it's a lot, it means there is a car. If there is not a lot of them, it means there is no car. So how can we count? So we can count simply by writing count is equals to cv2 dot non count non-zero pixels, and we have to give in our image, so it will be image crop, and that's it. So this will give us the count number. So now what we can do is we can write this count number in front of the box. So we can write here cv2 dot put text, or you know what, yeah, let's do one thing. Let's use cv zone instead. So we will write cv zone, no, not cv2, cv zone, cv zone dot put text rect, and we will put it on our main image, and then we will give in the text. The text will be basically our count, so string and count, and then the position will be, let's say the starting position is x and the ending position is y plus width, y plus height, minus, let's say, 10. So let's run that, and there you go. So now you are getting the numbers, but they are really big, so we need to scale them down. So scale is equals to 0.2. Okay, that's too small. Let's put scale is equals to 1. Better. But I believe there is an offset, and there is also a thickness. Thickness is equals to 1, and the offset is equals to 0. Let's try that. Yeah, so now it's much better. Maybe we can increase the thickness a little bit. Thickness is 2, let's say, and the scale is, let's say, 1.5, and we can push it a little bit further. So let's say -5 instead of -10. Yeah. So now it is showing us the value of each of the cars, and you can see that 1500, 1700. Actually, let's make it a little bit smaller. It's too big. Let's put it as 1, and let's make it -3. Yeah, now it's better. So yeah, so you can see here that these are all filled up, and the empty one, you can see the value is very low. The difference is huge. So here you can see it's 1700, 2000, 1300, and the empty space is 400, 500, or 400, 200. So there's a big gap. So what we can do now is we can put all of them, and then we can check what is the minimum value, what is the maximum value, and then we can find something in between. So let's go back to our parking space picker, and here we are going to select all the parking spaces. So let's remove this one and put it back again. Again, it doesn't have to be perfect, it's just an estimate. So whenever you make a mistake, you can reset. I think this whole area is done. Yeah, one of them is done. Let's do it for this one. I think the height might be a little bit bigger than the actual size. You can change the height later on as well. From the main code, it's not a big deal. So all of this is done as well. Let's go here. Okay, so this is done. Now we can simply close it and go to the main and run it. And all of them should automatically, oh, you can see there's a lot of images being created. Actually, we should delete that. We should, why is it so far away? So, as I mentioned, the camera is actually moving a little bit. So by the end of the video, it's almost to this point. And by the start of the video, it's a little bit shifted. Again, you can play around with these values, but it should still work. So let's stop this. And first of all, we will remove this I am show because that's putting up a lot of strain. And we can also remove these two images. And let's run that. There you go. So now you can see that. So this is an empty spot and the value is 600. This is an empty spot, this. So 600 is the maximum till now. Then at this point is 400 something, 100 something, 200 something, 200. So 600 is the maximum we can see here. But to be on the safe side, we can put it as 800. Anything above 800, because we can see that the ones that have cars in them, they are above 1,200, 300. So this is 1,200. This is the minimum one. Where else? This is 1,100. So this is the minimum. This is 1,020. So we should not definitely go above 1,000 for sure. But I think 800 is a good place. So it's in between. So we can say that if it's below 800, there's no car. If it's above 800, there's a car. So we can, where is the count? So this is the count. So we can say if the count is less than 800, then, and then if else this. So if the count is less than 800, first of all, we are going to change the color of the display. So if we are displaying with purple, let's make it green and red. So if it is available, it's green. If it's not available, it's red. So color should be 0, 255 and 0. And we can copy this and we can paste it here and we will say 255, no, 0, 0, 0, 255. So this is red. So if it's less than 800 means there is no car, then green, otherwise it's red. And we can also change the thickness. If the car is present, we want it to be, like if the space is available, we want it to be visible, more visible. So let's put the thickness as 5. And if it's not available, so then we can put it as, let's say, why is there's an extra comma here? Okay, we'll put it as 2. So it's easily visible. Okay, so now we need to display. So instead of displaying it again at the end, we need to display it there. So after the processing is done and the count is done, then we can do that. So we can bring it here. Actually, we need to remove it from here. So here we are going to run that. And instead of the color, we are going to put the variable color, and the thickness, we will put it as this. So if we run that, now you can see that the red regions are the ones that are not available and the green ones are the ones that are available. And it is pretty accurate. And as you can see, when the car leaves, it becomes available. So let's see that. Oh, there is a problem here. It's going to 800 plus. So either we need to change the values a little bit, or we can make it 900, let's say. So it shouldn't affect. There you go. So here the car is leaving, so now it's empty space. Here the car is leaving, now it's empty space. So that's pretty good. And as you can see here, this is a very good part. When the person is moving in between here, oh, it's still flickering. A little bit of flicker is fine. Okay, this is around 900. So that's not good. Ah, the placement is bad. Okay. So I think we need to, the problem is the camera is moving a little bit. So that's why it's a little bit difficult. So what we can do is we can go to back to our parking spaces. This one, we can push it a little bit back, all of them, so that it doesn't have a big effect. Like even the camera movement, it should not have that big of an effect. But again, the best part will be to actually stop the camera from moving. That will be better than doing all of this. And I believe this one as well, it was moving a lot. So let's run that again with the main. And yeah, now it's not flickering. This one is flickering because the car is leaving. That's fine. But here you will see the interesting part. When the person is coming inside, it's not being detected as a car. It's still space is available. So that's good. So it means if there is a big object, if there is a big car, then only it will detect. So here you can see it's leaving. So it becomes green. Here as well, it's about to leave. So it will become green. So that is pretty good. But I don't like that this is purple. Let's make it red as well. So the CV zone, where did we put it? Oh, okay, it's in the main. So here we can change the color. We can change the color of the rectangle, and we can make it red. So 0, 0, and 2, 5, 5. So now it is red. So you can see. So it's red and green. So the only thing left now to do is to check how many spaces do we have and how many total are there. So because we didn't actually count them. So what we can do, we can put it after the for loop. Yeah. So every time it counts, we are going to add to our space counter. Space counter is equals to 0 and in the beginning, and every time it is less than 900, we will say space counter plus equals 1. And at the end of the day, we are going to display it. So we will put again, let's put the text rect. We are going to put it outside the loop, outside the for loop. And this time we will write space counter. And let's put it at, let's say 100, and the height as 50. The scale, we can put it as, let's say 5, thickness as 5, offset as 20. Color, we can keep it purple. So let's just keep it that way. Or let's put it green, better. I think green will be better. Scale is too big. Let's put it at 3. And we will write here color. Rectangle is 0, 200 and 0. Because 255 will be too bright of a green. Yeah, there you go. So yeah, 13 spaces, 14 now because it's 14 because it's left. And what else? Yeah, this one is leaving, so 15. But let's write something with it. So here let's make it an F string, and we will write here. What do we write here? Let's say free. These are the free spaces out of the length of our, so out of total, which will be the length of our position count, our position list. So no matter how many we have, 69, we have 69 spaces. So 13 out of 69 are available. So this one left, so now it's 14. This one left as well, so now it's 15. So these are the free spaces that we have. So yeah, so this is the basic idea of this project. And to be honest, it's quite simple, and you can see that a very simple approach can be powerful as well, as long as you are using the correct method. It should be robust enough and it should give you some good results. Actually, let's change the color of this as well. Um, so we are putting the text, no, we should put it after. So we should put it here, let's say. This is for the count, yeah? So we should put the rectangle first and then the count. And we can use the same color scheme that we had there. So the color is this, and the thickness, okay, so the thickness we don't care about. So the green ones will be green as well. So the number of theirs will be green. So I think, yeah, that looks better. Yeah. So this is the basic idea of this project. I hope you have learned something new. If you like the video, give it a thumbs up and share it with your friends. If you find it useful, then give it a comment below and let me know what did you like, what did you did not like. And I will try to come up with more of such examples. So this is it for today, and I will see you in the next one.